Hi everyone, and hello Johnny. Today is our second guest lecture in this course, which I think going to be very much fun, because I haven't actually realized that there are the departments that analyze sensor data at the Swedish Police, but it does make sense, right? So you use IoT data for investigating crimes. And today we're going to learn more about it. So, Johnny, what do you do at the Swedish Police? What is it called?
Yeah, my role is as a forensic expert. We do a number of things. We are sort of divided into different areas. One area that I am more into is hardware forensics, meaning that we analyze the hardware of these devices that are sent into us. We also have a software engineering group that analyzes software and reversing them. And the last thing is also, well, research and development, which I am part of, a great part of, actually. The idea is to get data out of hardware and software in order to analyze them. And I will present this in my presentation, what forensics is and what digital forensics is, and moreover, the IoT forensics as well.
Awesome. I'm going to put the presentation on here, and I'm going to give the screen completely to you. So I'm removing myself now, and the stage is yours, please.
Thank you. So the agenda for this presentation is, well, I'm going to declare a little bit what forensic science is and forensics, and then further dig into Internet of Things forensics, which is obviously the topic for this course, or at least the IoT part of it. I'm going to present some examples that we have had here at the lab, and finalize this presentation by having an open question and general discussion regarding not only forensic part, but also IoT designs in general, due to my hardware background. So what is forensic science? Well, it's a sort of umbrella definition of different kind of sciences, but it all relies on the cause and effect. If you do something, you might expect something to happen, and this helps you to backtrace things that already have happened, so you can estimate the cause as well. There is, well, the father of forensic science is said to be Edmond Lecav, and he had this number of books called Traité de Criminalistique, which is sort of a collection of different kind of topics with regards to forensic science disciplines like fingerprints and medicine, forensic medicine, and all of everything. What we have is, regarding scientific methods, well, typical for them is, well, it's applied onto criminal investigations first and foremost, and evidence examinations. It all relies on different kind of sciences: physics, chemistry, biology, math, statistics, and everything else, but also other domains like psychology, which could mean cognitive science or behavior science and such. We also use different kind of evaluations of both hypotheses and the results we get from the forensic analysis, like, well, Bayes' theorem is one of the more famous ones. Regarding digital forensics, the fundamentals are more or less the same regarding forensic science, but digital forensics is sort of put into their own track. And this is probably, in my opinion, it has to do with the idea of not only bringing forensic science discipline, but also add the different kind of applied things like several human inventions. We're using the terminology in other disciplines like STEM, science, technology, engineering, and mathematics. So having technology and engineering makes it a little bit difficult, or something else in comparison to traditional science, forensic sciences. In this case, if you have, let's say you have a black box, and it has the ability of counting 1, 2, 3, 7, 8, 10, 11, and you're thinking, oh, you missed some digits there. No, it's was the specification that they mentioned that it doesn't have to follow all the sequential numbers, or it could be that let's say that you have a specification that does it, or a very vague specification of design. Or it could also mean that, well, there is a flaw in my software, or there is a flaw in the hardware that executes the software, or flaw in the libraries that you have used for compiling your software code. So you cannot really determine in full or expect that things are about to behave as in the same way as traditional forensic science, because there are so many other options. You could rely on to, let's say you have very short time of development, or you rely on other people's code, for example, then it might end up in whatever result you get. So having 15 engineers to do the same solution or the same end result might have a number of different solutions in order to reach that end solution. And this makes it more difficult to just predict how things are really working. It can also be said that umbrella discipline, as digital forensics is some kind of umbrella discipline for hosting many kind of forensics. The most well-known ones are, for example, computer forensics and mobile forensics, but there are a number of other ones like vehicle forensics, where we take a look in how the devices in the vehicle works. There are a lot of components that store data. For instance, the infotainment systems or telematic systems and such, which could give clues of what really happened. Network forensics, or in this case, IoT forensics, which I will dig deeper into later on. You can consider digital forensics as a science discipline where you do research onto different methods, or if you are looking into methodologies in order to form some general understanding on how things are about to be taken care of. Or you can consider it as a practitioner discipline as well, where different practitioners like forensic experts or forensic specialists or a number of digital forensic practitioners that are collecting evidence or analysis evidence from a crime scene, for example, the digital materials that are in there. The very idea of digital forensics is to find traces of what there is. How can these predict or perhaps mention or give an idea of additional things that have happened? Nowadays, it is said that in most cases there are digital equipment that could be of interest for another kind of criminal case, where you're using a smartphone, for example, to take pictures or take notes or record things. And you have also a lot of cases there is no mobile phone or several mobile phones involved, or smartwatches when it comes to well, deciding positions, or you have brought it with you along committing another crime. Regarding IoT forensics, well, you can see that, well, it has common with Internet of Things in general. So everything that are related to Internet of Things could be of interest when applied onto criminal investigation, for example. So, well, as for many IoT devices, you will expect to have or to see some processing device that does some logic decisions. You might expect some kind of data processing or data forwarding to something. You might have some RAM or an IO port where you communicate. These could be the keys to extract evidence, for example, that could be analyzed further in a forensic investigation. And the most important thing is where you can find persistent memory, and that might be a tricky thing to read out memory, because it could be corrupted or encrypted or protected that you cannot directly access it. You might also think of some kind of network connection. It could be directly via Wi-Fi or so, but indirectly via Bluetooth to a mobile device that they connected to, for example, internet or an internet service as well. In our cases, we also expect to see some sensor data, or perhaps if the device you're looking into might be an actuator or some kind which contains data as well. Well, to give some examples related to the IoT forensics, there have been some research projects or method development projects or exploring things to see if there are something of value for a potential forensic investigation. So we have had an ongoing project called, well, it consists of a home automation system called Vera plus an additional device called RFX TRX 433, meaning this later device also had the ability to pick up, to receive, and to transmit commands on the 433 megahertz ISM bands as well. This led to new ideas regarding, well, there was the outcome of this research was to more or less understand how home automation devices might be of use when it comes to forensic investigations. So one of the outcome was to methodology that could be potentially applied onto the other kind of devices, or the learning experience from it at least. This also led to the Atom Home Pro project that was hosted here as a bachelor thesis project as well. The second thing is building information and control system forensics, which is a sort of term that's well, I have coined sort of some other people, but there are not that much research regarding build automation and control system forensics, at least just a few number of papers. So I wanted to look into this and to see if there was a possibility to retrieve data and to analyze sensor data for potential digital forensic usage. So and the learning experience from this is that we had, well, yeah, well, I'll present it throughout the next slides. I will also present a case or a few caseworks that we have had at our forensic lab as well. The idea is to, well, I think I can actually show them to you. So the home automation forensics, this is a sort of a sensor and actuator event-based timelines. The idea is to retrieve data in order to put these timelines sequentially. This might give an indication of what you can see in terms of sensor events and actuator events. And it proven to have worked very well because there was a scene, a made-up scene that was carried out. This consisted of, well, one person that went to sleep and one person that played the perpetrator, which was me, obviously. So I broke out into my own house and did a burglar thing, and all these sensors were registering my and the victim's presence and what we were doing, like turned on or turned off the lights and moved into server rooms. Yeah. It is important to know that all these are not pointing who did what, but rather what did the sensor and actuators register at a certain time. The Atom Home Pro thesis work, as I mentioned, relies on the ideas, or is based on the idea of or the experience from the Vera Plus project. So we had two thesis workers, Rosa Baghari and Carolina Nyqvist, who conducted this bachelor thesis work at our place here on our training facility. And it turned out to be very successful. We managed to retrieve data out of the home automation controller device, and to analyze this, we just did a chip off and read out the data, which was fully unencrypted. Luckily, 3 fully readable Linux petitions, and there was some databases that we could look into further. Yeah, regarding test scenarios, well, since both of these are made up scenarios, but under very controlled forms, so we knew what to look for, and it could be expected that not everything is registering in real life, but it's good enough, at least in terms of supporting or rejecting initial hypothesis regarding crimes investigations or crime scene reconstructions, at least. The second thing is the project, research project that I mentioned before. It is based upon different sensors. Can we predict something that happened in a building automation and control system with help of the sensor data that is already being registered there? A back system consists of a number of sensors in order to collect data for and to govern a building in terms of heat and temperature and indoor conditions in general, and to collect data for maintenance planning and room planning and such. So there is always data in a building, in a modern building at least. So by using these kind of sensor data in terms of forensic investigation, there is very little work done on this. So in this case, 2 sensors have been focused on. The first sensor is a carbon dioxide sensor. This is a very precise and very rapidly changing sensor. The idea of having a carbon dioxide sensor in a room is to measure the exhaled carbon dioxide into the room and possibly to force the heat, the AVAC system for having a better air inside the room. So you can force the ventilation if you have put up some rules when the CO2 values are too high, for example. The second sensor is the passive infrared sensor. This is for detection of heat movements, especially human bodies when someone moves in the room. It notices presence in this term. So the idea is to pick up this kind of sensor data in order to govern lighting, for example. You don't want to have your lighting turned on off working hours. So it's better to use this kind of sensors. Or if you have you can also control, for instance, the HVAC system. There is no reason to force ventilation if there are no one is present in the room for a long time. So in order to also question this sensor data, I did also some data manipulations, you can say, or sensor attacks. The idea is not to troll the sensor just because you control the sensor, but to demonstrate that it is actually possible to alter or sensor data or hide away from sensor data. And this is with regards to the forensic aspects. Do you really rely on what data that are present? Are they complete, or are there any misbehavior or misconduct of the sensor? In this case, I've used a drone and emergency blankets to conduct these. An example is that one of my colleagues, who is a drone operator here at the lab, he flew this drone indoor, and I brought a thermal imager camera for demonstrating the heat from the electronics. And as you can see on these images, these are becoming quite warm when flying the drone, and this triggered the peer sensor. So by this you can implant false positives, and then you can question, have there been any persons in this room? You can tell it by this peer registration, and the answer in this case is of course no, there have been no people, but you cannot separate them from just looking into the figures in the sample data. The opposite is of course to use rescue blankets, which sort of encapsulates your emitting body heat. In this case, you can escape or evade from peer detectors, so you can go completely blind from them. Well, traditionally, or I would say normally, you won't expect this to happen, but I mean, if I am able to hide away from sensors, then probably other people can do the same. And this is to demonstrate that you cannot only rely on one piece of sensor data. And to explain this further, I have done some carbon dioxide manipulations. But the yellow curve indicates the level of carbon dioxide expressed in parts per millions in this room, while the blue is binary sensor data 0 or 1, present or not present. I enhanced them by 400 just to have these in the same graph to illustrate that. So the first block, leftmost block, indicates when I enter a room and breathe normally, meaning that I took the air inside the room and exhaled in the room normally. Then the middle block, then I went out from the room quite often after that, and waited for some time, and entered the room the second time, the middle block, as you can see, the blue block in the middle, that indicates a new presence. And as you might see that the curve slowly goes down to the side value, approximately around 400 ppm. If I would enter the second time without exhaling my I use this inflatable mattress to exhale my carbon dioxide. So in this time, I fooled the carbon dioxide sensor to believe that there are no carbon dioxide increasing, while the presence notice that someone is in the room, or at least some hitting body moves around in the room. And I repeat this a second time, so the third and the rightmost curve also demonstrates a presence of something, meaning me in this case. But the carbon dioxide value is going down approximately to the side value. And I use this inflatable mattress to exhale my carbon dioxide the second time. By this, you can, by sensor fusing, you can see more than you relying on just one sensor data type. And this is more of demonstrating that it's very important to look into more data than there actually is. Regarding casework, we had some cases regarding IoT forensics. The first example is a remotely initiated arson. In this case, the house owner, he had a house in Sandviken, which is around mid of Sweden, more or less, approximately. And he had met some woman down in Thailand, and he asked some person to watch his house while he was away. So he worked for some months in Sweden, went out to Thailand, met this woman, and back and forth all over. And all of a sudden, his house started to burn, or the suspected arson. So the fire investigators, someone claimed that, oh, the lightning might have struck the house, but they dismissed that suggestion. And it could be told that on the upper floor there was some fire residues from before. There was actually one device, a Wi-Fi connected smart plug, inserted into the wall. And the second smart plug was thrown into a paper bin, and the receipt and the emballage for another device then was thrown in the paper bin. So it was suggested that the first or the device that was thrown into the paper bin was of another brand that was sitting in the wall. So other colleagues, they investigated the remains from these devices and concluded that, well, according to the emballage, the device that was sitting in the wall, or the remains of it, is most likely to be the same as the emballage. There was also fingerprints on to this. The second one that was thrown in paper bin was of another brand. So thereafter, we got this information to where I'm sitting at the forensics. So we purchased 2 new devices, 2 test devices, and me and one of my colleagues, we had this technical examination of this case. So we purchased these test devices, and we configured them with a mobile phone that was rooted. This means that you have full access to everything inside your mobile phone. It seems that the first one that was thrown in the paper bin, you needed to register a user account in order to use them outside your own Wi-Fi network. While the second smart plug, you didn't need to do that. You just paired it up, and you were set to go, even being outside your internal Wi-Fi network. This meant that, well, we draw the conclusions that, well, I was sitting back at my home while my colleagues were at our office, and by turning on and off desk lights, we conclude that if this is possible between 2 neighboring cities with an internet connection, it is probably likely to do the same from Thailand and turning on off a device in Sweden if there is an internet connection. It is worth mentioning that the residuals from the fire, they consisted of in the smart plug there was also a soldering iron put into, and the soldering itself was put into a robot vacuum cleaner. So the robot vacuum cleaner initiated the fire actually. So what happened? The house owner sounded very surprised when he heard that his house catched fire, and thereafter, after a number of interrogations from the investigator, he concluded that this must be the perpetrator, or instead of being a victim, he immediately became a suspect for this arson. And yes, this was happened. Our tests that later on showed when he became a suspect, that we got these tablets, an Android tablet. Colleagues of us extracted the flash memory, and we analyzed the contents of it. It seemed that there were especially one database that existed that was of very interest, and that was SQLite database that was registering purchases done in Google Play. The two apps were deleted from the device, so we couldn't find any remains from it, which we were expected to see if they were still there. At least according to the test device that we used, the rooted mobile phone. But we could see from the one of the databases here, for example, it contained an app that indicated that this app was installed in June 15, 2018, and the other app was installed 27th of July 2018. The arsons started the 31st of July 2018. So both of these have obviously been installed prior to the arson, at least. And so we draw the conclusion that well, this might be an indication. And our investigation plus numerous other investigations in total could point out this house owner as the cause of the arson. The fingerprints also indicated that he had handled the emballage for the smart plug that was put into the wall as well. Here are some medias written in Swedish, but you can see that you can read more about it. The second example is web camera analysis we did. We purchased a test device. The real case was a webcam filming a object, a military facility, which isn't allowed in Sweden. It was powered by a 12-volt car battery, which is a used one, and a 4G router. So we purchased a test device and populated with test data that is known to us, and we managed to retrieve it by all data that were populated in the flash memory of the webcam. And so we managed to actually trace back a lot of interesting information that from the test device, and we concluded that we would probably expect the same similar data in the real case. So we did a ship-off of this real case, and we could see that it also contained user information and timestamps and other interesting parameters that described the usage of this webcam. Third example is portable THC and CBD analysis, which is used for determining the amount of tetrahydrocannabinoid and cannabinoid. Well, if you're using weed, for example. This device was sent in initially to us only. By looking at this product, we could see that well, as we suspected, this needs a controller device, a controller app. So I found one of the forensic experts in the region that were responsible for this case, and she sent me the image of one of the mobile phones that were suspected to be used in this case. And we did some analysis of the image, which was an iOS image. We could see that, for instance, the broken MAC address were equal to the one that was in this device. We can see a number of other indicators in different databases that indicated activities and connectivity. So we drew the conclusion that this device has been paired with this iOS device. We also conducted some own tests with together with the drug analysis section. So we got some test samples to measure, and we could also conclude that these mobile phones also have the ability to store the amount of samples data that was measured. Here are some work that we can look up if you're sort of interested in IT forensics. So what's more interesting, in my opinion, is if there are any questions or general discussions regarding IT forensics, not only, but also IT design in terms of RF design, in terms of power consumption, uses of different kind of flash memory technologies, and ethics or legislation, and all these kind of things that are needed to know regarding hardware design and user interface as well. So feel free.
Trying to rearrange here. I don't know if that's worked. Like, here we go. Yeah, thank you. Sorry.
Oh.
You don't want it.
I can share the screen again.
Yeah, if you want to keep the presentation there, if you want to go back and forth.
Yeah, that's true. Yeah.
Here we go. I think this was very nice, very interesting, and it's a pretty big field, right? So we can't really cover like everything today, but I think it was a nice overview. I think maybe a bit was difficult to follow your thought process there in that example case, right? How like it's pretty complex how you kind of.
Yeah, I've opted to have quite short versions, or extremely short versions of everything, because I would like to leave some room for discussions rather than me presenting a lot of things. And better have questions afterwards if there were any.
Yeah, we can take like here is like the first question from the audience, I think, while we still have the presentation. So why using the commercial sources?
Yeah, no, it could be anything, because why we choose to use At Home in favor for home assistance, for example, which is an open source project where you can build your own home automation system. Wow, a lot of people are not that dedicated to make do-yourself things. So we thought of by purchasing a commercial device, which are more simpler to configure and to have this united well, that could be a starting point. Having a do-it-yourself project is really good if you're into configuring on a very low level, but we might expect to see a lot of commercial home automation systems there. And so in order to, since you're able to sort of modelize in another way when you're having open source projects, well, it could be, but we opted for a commercial product and commercial available off-the-shelf devices, peripheral devices as well.
How it is in terms of like data security on these devices, and in general when you choose to work with it, like data ownership and like where it goes? Are there any limitations of what can and cannot be used?
The legislation is a little tricky. I think they have changes a bit, so you're able to retrieve that is also put into the cloud nowadays. That wasn't prior to now. But we look into offline or dead items that are sent to us, meaning that, well, here's the device, look, see if you can find some traces inside the box. Regarding in terms of encryption and such, it differs a lot from different devices. Some devices are very locked down, where you have two boot stages in order to, and then the OS that is behind, which gives a very secure device. While others are, well, it is various devices, so you cannot really tell if. In most cases, there are no reasons to actually protect the data. Well, it is, but in order to get a short time to markets, a lot of manufacturers that they just use what they have and put it out there, having very little thought of the security aspects, unfortunately. But perhaps good for us.
Yeah, right. Another question here is more practical. So what kind of hardware do you use to extract data from memory chips? You mentioned it, I think.
We are using tools like, in order to remove data from, or read out, extract from, you can do it in different ways. Either directly by bringing it from the PCB directly, or you do a ship off. It depends on how the design is configured. The less invasive methods, the better it usually is. There is always a risk of corrupting data in worst case, or corrupting the device. So if you're able to identify test points, for example, or other ways to retrieve data without desoldering any flash memory, for instance, that is better. But the last thing is to desolder the flash memory, and we have a number of tools that are able to decode or the information that is retrieved from the flash memory as well.
Thank you. Then this is, I think, a very interesting question. I can put this down first. We kind of planned anyway to talk about ethics, right, and the legislation surrounding working with this type of data. I guess there are slightly, I'm assuming that the police and maybe other state organizations that have to do with security, and they're kind of exempt from a lot of these rules. Am I wrong?
Yeah, we don't consider the GDPR perspective at all, because we got this device or anything that might bring the investigation further on. So we cannot sort of self-censor ourselves in terms of this. We get this even if there are very personal data that is stored onto the device, whatever device it might be, USB, memory, or mobile phone, whatever. We cannot consider that. We take the whole information and we adjust it to the investigator regarding certain questions, because they are not interested in everything. They're interested in what could bring the investigation further on. So, but I mean, if we have, for instance, if we discover, let's say, child pornography, well, we have to report it separately and handle the device separately. But otherwise, well, for us, it's not interesting to see personal information. We are only looking to try to find traces that are related to the suspicious crime.
But in general, when you like, what is your both personal and professional opinion about this? A lot of data that is being gathered everywhere, right? And sure, maybe for a good cause, but like, what are the risks here as well?
Well, the risks, example for uploading into a server or cloud solution. Yeah, the ability of doing a proper examination, a forensic examination, is a lot better, of course. And regards to legislation, well, it's not really my position to judge, really. There are other departments that are more into the legal aspects of data.
Yeah, but what do you think personally? I mean, if we talk about digital forensics, for instance, what do you think about the new chat control law that is being considered now in the EU?
Honestly, I don't have any options. I do as I no, I have no, actually. No, there are other persons or positions that are more into the details of all these alternations of legislation. So we do our things here. Don't really mind this because it's not of concern when it comes to of these kind of. It's more of. I mean, if you're a manufacturer or producer or developer of some kind of IT device, for example, you have to be fully aware of what is being sent and if you use consent and all this. But we are not really, what would I say? We don't really care.
Yeah, you don't really.
We cannot care. No.
Yeah, that was my impression as well. That's sort of, if there is an investigation that is officially open, then you can get access to the data that you kind of need to investigate, right? So that is understandable. I want to talk a bit about, when we still have time, how did you end up doing what you're doing? So like, if you can introduce yourself personally, like, what did you study and how is like, I'm going to apply for this job?
Actually, I didn't, or rather, when I did my own studies, my ideas were to get a foothold to the defense industry, because I found this quite interesting, because they are using the very advanced emerging technologies. So applied for one big company in Sweden that is situated in Linköping, well known for a certain type of fighter jets. So, but I didn't hear from them at that time, and but the predecessor to NFC or SKL, Statens kriminaltekniska laboratorium, they contacted me. Oh, you have sent an application for doing your thesis work here. Did I? I couldn't even remember that I did so. But I didn't. I wasn't aware of forensics at all, and was not really interested in criminology or such.
You're studying computer science, right?
But, so I accepted it and did my thesis work. Hardware analysis of a write protecting device for hard drives, which I commonly use in digital forensics when you're about to make a clone or image from a hard drive, for example. And then after, the labor market was very dark, so I worked for half a year in another place in electronics manufacturing industry, and when after that, I contacted the former SKL and asked, "You don't have to have a position for a project work or similar?" I couldn't get anything else but a no. But that former boss, head of group, oh yeah, we have a position that you might be interested in. Yeah, what's that? Well, we are thinking of building a computer cluster, and we want you to look into it and also develop a parallel parallel software for this. So I took the challenge. I'm not a programmer by heart, but I can manage a bit. So I developed a parallel password cracker, or the MD5 hash cracker that supports both dictionary-based and brute force, which later on turned into a conference paper in a conference. So yeah, and that's after my project employment was sort of finished, or right before. So that head of group asked me if he mentioned that, well, here is a position. It would be interesting if you consider it to apply for it. So I did, and now I'm here. And today I'm also part-time as an industrial PhD student at the Linköping University, hence the building automation and control system forensics project. Yeah, that's my thought.
Yeah, sorry, I said you study computer science, but it was electrical engineering, right? So that's why I say like you're.
Yeah.
So electrical engineering, and then you wanted to get into Swedish defense somehow. There was this project. This was this question here as well. Like, is it only Swedish citizens that are the sort of considered?
Not only. I think some positions are open to non-Swedish citizens as well. But you have to go through this security clearance, and if you do so, and you are able to speak Swedish and express yourself in the Swedish language, and then you're welcome to apply, I guess.
Yeah, so Swedish is important, right? Because
because this is our business language, so it's very important.
Yeah. Are there anything sort of other recommendations if you say I want to start in forensics? Like, what technologies should I know, or what should I?
I wouldn't say that I can point a certain thing, but it's constantly shifting. Now they're talking about how can we utilize neural networks or AI, or for forensics, or other aspects would be, well, how can we cope with sensor-driven data in forensics? Well, and I mean, if you ask me 5 years from now, my answer would probably be something else. So I don't know, really.
Yeah, but is it like, do you already use a lot of AI algorithms to kind of automatically process and alert things, or?
Not within digital forensics, because it's not that evolved yet or matured. But colleagues of mine, they have developed an AI tool for video and image analysis. So you can take a lot of video streams, put into their system, and look for a red coat, or a blue jacket, or a green bag, or whatever.
Yeah,
and
okay.
They go through all these video materials in order to identify candidates that might look like it. Or OCR reading for car plates or faces, and face comparisons and such. So it's a very modular system that are well, it is a product that works quite well already now, and has been used in a number of cases. And they are still continue to update the training things for miscellaneous items that could be of interest for an investigation.
Cool. There's another question from curious students here. So we have many students that study like embedded development, or in some way like on the edge of this computer science and IoT, right? So if they have such type of education and the skills like from this course, for instance, is that enough, or do they need some kind of forensic courses, or?
No, the forensic courses are not very important, because you'll get the necessary training here. it's more important that you can bring something to the table rather by very special skills and or have a mindset that you're very open to learn new things and to evolve and to cooperate. So no, you don't need to have a forensic background because that's the sort of additional training you get here in order to work here.
Yeah. How does it actually look like in the team? So are there like investigators or detectives? I mean, I'm just thinking like, you know, serious bridge. If you
different countries have different kind of legislations. Sweden's got one united police authority, where the Swedish National Forensic Center, where I'm sitting at, is a national department. While other countries have more than one legal law enforcement agency. For instance, countries like, let's say, France, they have France Police and they have Gendarmerie, which is a paramilitary police with similar legal legislations and restrictions.
But like, if just we talk about your team, like
my team, my team consists of both a mix of hardware and software skilled people, and oh, sorry, what was the question again?
Yeah, so do you work with like investigators or like some?
Oh, yeah, we do work with investigators during casework, and otherwise we do a lot of research and development within case-related work. So we try to foresee in the future somehow with regards to the trends that in terms of cases. So we can sort of predict of the future, something what's to look for into the future. Yeah. So now currently we are aiming for a really huge project where we look into hardware risk, hardware hacking, actually, or down to very low level, very advanced technologies. And this will probably be better announced when we have some of the results.
And I don't know if you want your presentation again, but I think somewhere in the beginning you mentioned that you have a project with Linköping University, right? So there is like a research.
This testbed Ebbe Park is my research project. Together with Linköping University, where I'm also sitting, and Sankors Fastigheter, which is a company, real estate company that hires out office buildings, for example. So they have a test bed among two other companies, real estate companies. All of these three companies, Sankors Fastigheter, Lejon Fastigheter, and I don't know. I forgot the name.
Yeah, that sounds better.
Yeah. So they have this collaboration regarding sampling data, smart house data or smart building.
Yeah. Yes, I think this is like important to mention to students because if you're interested in the thesis work, this is like how Johnny said he was also got into this field. If you are interested to work with this, there's a great chances to have your thesis somehow related.
Yeah, exactly. And there is also a chance of, because these two females that I mentioned before, that the thesis work or the FOMI, they both are part of our team nowadays. But it took some time because they went out on private sector and then went applied for positions here.
This is how we got this is how I got the contact with Johnny as well. We have Martin, who works at LNU part-time as a professor, and he knows everyone and everything in IoT, and there's a bigger lab in Linköping, and they collaborate also here with Johnny. So it is possible, even if you're at LNU, to get a thesis work supervised and done in Linköping. So that happens if you are. So if you show initiative, it is possible. So I think we have to wrap up, right? Because we're already a bit over time.
Yeah, I'm a meeting here that starts off quite soon.
I would like to thank you. And if you guys have any more questions, I will leave Johnny's email in our Discord if you want to contact about some specific technical thing. And Johnny, please send me your slides as well, so I can. There's a few people who asked about that. And yeah, thank you for this interesting presentation. Super cool detective content here. Thank you.
Yeah, thank you. And see you around, perhaps. Or
See you. Yeah. I will probably see you around. Bye bye.
Bye bye.